And here's a suggested solution to question 2 in the 2015 paper 4 sample paper for the 9608 computer science syllabus. So it's a decision table question. It's pretty straightforward. This is the scenario. A manufacturer has an assembly line that produces a particular product. At the end of the assembly process, each product item is comprehensively tested. So here we've got a set of 3 tests, and depending on the combination of testing, an item is either going to be accepted, repaired, or rejected. Only if the item passes all 3 group tests is it accepted. So yes, yes, yes here will mean a yes here. If the group 1 tests are passed, but only one of the other 2 tests fails, the item is sent for repair, otherwise the item is rejected. So let's have a quick look at the solution to that. And this is the decision table. Hopefully you know how to create the order of yes-no conditions, starting with no, 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 which is the equivalent of 0, 1, 2, 3, 4, 5, 6, all the way up to 7. Okay? So let's have a quick look at the solution to this. An item is accepted if it passes all 3 tests, so there's only one of those. It's sent for repair if it passes the group 1 test and only one of the other tests fails. So it passed the group 1 and only G3 failed. It passed the group 1, only G2 failed. It passed the group 1, but G2 and G3 both failed, so that's not sent for repair. That is rejected. And of course, if it doesn't pass the G1 test, then it's going to be rejected. So that's the solution to the first part of the question. Alright, let's have a look at the second part, which was simplifying the solution by removing redundancies. I could only get this to work by starting over here on the right side of the table. So remember, when we're looking for redundancies, we're looking for 2 actions that are the same, but there's only one difference in the conditions. So there's a difference, and there's a difference. So there are 2 differences, so there's no redundancy there. Okay, so let's move on. Now, as I said, I can only make this work if I start on the right side. Anyway, same, different. Brilliant. So we've already got 1 redundancy. So let's delete that, and let's just replace it with a dash, and then we can delete those. Any more? Same, and 1 difference. Brilliant. So we've got another dash scenario. So let's take a copy of that and put it over here. And we can get rid of this one. Just get rid of that as well. Oh, that's a bit awkward. Illustrator. I'm going to keep looking. Same, different. Brilliant. So we can get rid of another column. So let's get rid of this column. And we'll turn that into a dash. And different. So I don't think we can do any more redundancies. That is the solution to the question. Okay, the final part of the question, the simplified table is used to design program code. 3 functions are already available. these functions return true or false, indicating the success or otherwise of the group tests. Write code for a function reject, which will return true if the product item is to be rejected. Otherwise, the function will return false. So all we're doing here is we're looking at the reject action, and we're just saying if G1 is true and G2 is false and G3 is false, or G1 is false, then the function will return true. Okay, so it's something like this. If, are we writing program code or pseudocode? Sorry, write code. Okay, let's write some Python then, I suppose. If G1 test is true and G2 test is false and G3 test is false. So that's the first set. Let's just put that into brackets. So, or so let's put all of this into brackets. Or G1 test, which is a function, remember, so we are using the brackets, is false. Return true. Else return false. Okay, so that's really the solution to that part.